topics were proposed. Okay, all these subtopics were proposed for OSPF. OSPF के अंदर ही आते हैं, तो आपको ये सब explain करने पड़ेंगे. Okay, so now the internet is made up of. Now, as I told you, as I explained, whatever topic concepts right now, all this concept falls under OSPF. क्यों? क्योंकि ये इंटरनेट के लिए है. So again, I'm repeating, whatever I teach you, everything has to be included as an answer for your OSPF. It is asked if it is asked in exam. हर चीज में जो भी बोलूंगी वो हर चीज OSPF का ही प्रोटोकॉल का हिस्सा है. It is not that कि प्रोटोकॉल कुछ और है, ये concepts है. No, all these are the हिस्सा of protocol itself. So now your internet is made up of something called as AS. What is your AS? AS is your autonomous system. Your internet is made up of collections of AS. AS is your autonomous system. Okay, your autonomous system is operated by different organization. For example, TCS, the network becomes one autonomous system. IBM, their network becomes one autonomous system. When we bring all these autonomous system into the internet, now all of these are categorized as an individual autonomous system. Okay, so now for example, you can say the internet network of companies is usually seen as three autonomous system. Okay, in each company you can say that it is made up of three autonomous system. What are these types of three autonomous system inside a company? That I'll show you later. Okay, if all the three are on the internet, okay, if all these three autonomous system of any companies are in the internet having some standard internet routing, then that will simplify the implementation. Okay, now to simplify the implementation at boundaries between autonomous system, that will allow us to reuse the code. Okay, for example, I have this autonomous system, this autonomous system, this autonomous system forming one network for the company for the internet. So there are various rules inside this, how it will interact with the another one over the internet. That is what we are going to study. So for that, because now we have seen, I've just told you that internet is a collection of autonomous system. That means in internet, different autonomous system are connected to one another. Okay, so because of this nature, your routing algorithm in TCP/IP. Remember, the routing algorithm that we studied before is the routing types of routing algorithm by OSI. Your dynamic, static, adaptive, non-adaptive is the routing algorithm by OSI. Now TCP/IP provides gave the basic structure for your internet, right? Gives routing algorithm of two types. So what are they? Whatever I'm going to write, teach, pick every single word. Okay, क्योंकि जब OSPF खत्म हो जाएगा, I might have used 20 new words, 20 new concepts that were proposed and implemented for OSPF. Okay, so your TCP/IP protocol divided your routing algorithm into two types. One is called as IGP. Another is called as your EGP. IGP is your interior gateway protocol. EGP is your exterior gateway protocol. So by now, how many words do we have for open shortest path first? It is by TCP/IP for internet. Okay, here it is made up of large number of autonomous system, and each company will divide its overall network into three autonomous system. And now this collection of three autonomous system will make one autonomous system that will be put over the internet. Now for OSPF to function, TCP/IP stack has divided routing algorithms into two parts. One is your interior gateway protocol, another is your exterior gateway protocol. Okay. Now, a routing algorithm within an autonomous system is your interior gateway protocol. So now this is an autonomous system, one autonomous system. This is one autonomous system. So these are all routers here, these are all routers here, these are all routers here. Okay. So now when this autonomous system has some name, this autonomous system has some name. ये autonomous system के अंदर तीन body होती है, हर एक का अपना अपना नाम है. So when there is communication amongst themselves, but within an autonomous system, it is called as interior gateway protocol. Now, when I have another autonomous system, okay, when I have another autonomous system and there is interaction between these two autonomous systems, it is called as your exterior gateway protocol. And we need interior and exterior gateway protocol in open shortest path first. Why? Because it is an internet protocol. Okay? हमें दोनों ही चाहिए क्योंकि अंदर भी तो फंक्शन करेगा, अब वो बाहर के इंटरनेट में कनेक्ट करेगा. So we need both IGP and EGP. Okay? Both are the proposed idea for your OSPF. Okay? So now you have understood IGP, EGP. Now, the original internet, that is your internet gateway protocol, was a distance vector protocol. Okay, you know that it is based on your Bellman-Ford algorithm. Your interior gateway protocol was a distance vector routing protocol. Okay, it worked well in a small system but less well as autonomous system got larger. Why? Because we have already studied that your distance vector routing algorithm suffers from count to infinity problem. I've told you to self-study count to infinity problem. If those of you who have studied, by now you might have known that as the size of the network increases, count to infinity problem becomes more complex. So, because IGP uses distance vector routing algorithm, as the size of the autonomous system increases, the count to infinity problem also increases. Because of that reason, in 1979, okay, so because of that reason, in 1979, in OSPF, your distance vector routing algorithm was replaced by your linked state protocol. Linked state protocol. Now, I told you when I was teaching you distance vector routing algorithm that it suffers from CIF, count to infinity CTF, count to infinity problem. So it was improvised and a new version of algorithm was proposed. It was named as your linked state protocol, and now your linked state protocol does not suffers from your count to infinity problem. So because of that reason, in 1979, your distance vector routing algorithm in OSPF was replaced by your linked state protocol. Okay. So now in 1988, the internet is ruled or standardized by a force called as IETF. IETF. Okay, the full form is Internet Engineering Task Force. They are responsible for handling whatsoever of the internet related things. Okay, so now in 1988, IETF Internet Engineering Task Force worked on a successor. Okay, and the OSPF routing algorithm was proposed as standard in 1990. So with all these changes, whatever had to be proposed, OSPF was in development. So the idea of autonomous system was proposed. Each autonomous system having 3 sub-autonomous systems were proposed. And then it was decided, okay, in interior gateway protocol, distance vector routing algorithm will be used. So it suffered. So then it was upgraded as linked state routing protocol. And in 1988, IETF came into the picture to take care, to standardize OSPF. And by 1990, IETF made OSPF a standard routing algorithm for internet. इसको OSPF को अब स्टैंडर्ड कर दिया. So that is the reason in internet OSPF is used. Okay, so we have studied till here. So any questions till here? What is OSPF? What is IGP, EGP?
No.
Okay, so now let me explain why the keyword O. Okay, let me go step by step. Now next, most router vendors now started supporting OSPF. Okay, now most router vendors like your data link, here. I don't mean layer. Okay, so there is a company there. I don't know if it's still there or not, but during our engineering days, there used to be just like Cisco. There was Data Link. There was many other routers which manufacturing companies. Okay, so now these router vendors, they now started supporting your OSPF, and they started implementing it in their router, and then it became one of the main IGP. Okay, so it became one of the main interior gateway protocol. A distance vector routing, later link state routing protocol, became one of the main IGP for the OSPF. Okay, for the OSPF. Now, because it was about internet and the journey in itself from ARPANET to 1990, there was an alarming increase in the size of the internet, which was originally thought to be an 8 computer-based network, ARPANET by DARPA. जो 8 कंप्यूटर का उन्होंने सोचा था, 1990 तक आते आते कंप्यूटर का साइज एक्सपोनेंशियली ग्रो हो गया था. So they could now vision, in 1990 they could now vision how big it was going to be. So they had to come up with the OSPF. Okay, and it is about internet. They cannot keep changing things, right? Every other day, if they will come up with new routing algorithm and every network has new routing algorithm, then it will not be compatible. One network will not be able to talk to another network because the protocol is entirely different, and one doesn't know the functioning of the others. Everything has to be upgraded, everything has to be changed. So the idea, the implementation of OSPF had to be crisp and clear and should meet all the requirements. So certain points, rules were framed for OSPF. Okay. Now, given the long experience with all the routing protocols, long experience with shortest path routing algorithm, first shortest path routing algorithm, flooding, selective flooding, your distance vector routing algorithm, your link state protocol, your routing information protocol. Given a long history of the experience of various routing protocol, the group designing this new OSPF protocol came up with a long list of requirements. Okay, came up with a long list of requirements. The first was that the A had to be published in the open Digexpress. Okay, they came up with a long list. The first of the list was first the A had to be published in the open Digexpress. Hence, we use the term O in open shortest path first. Okay, a proprietary solution owned by one company would not do. No company can own one particular solution. Okay, I'm going to use this. No, then you are out of the picture from the internet. You may use anything inside in your, but at the end you will have to have link state for your IGP that will communicate with the EGP. Okay, and then whatever packets you have. Okay, so whatever packets you have, that for that I'm using the term A. Whatever is there that you want to inject into the network, this has to be published in the open network. ये जो आया है राउटर ए कि इसके बारे में ओपन नेटवर्क में पता होना चाहिए that such kinds of router exist. That is why the term open. First, the A had to be published. This A router had to be published in open. Hence, we have the term open shortest path first. Okay, because it's this OSPF is huge. If there is any doubt, I'll not ask you, is it clear? Is it clear? You yourself will unmute yourself, stop me in between and ask me your query. Okay, so that was your first, that your A has to be open. Okay, so the second requirement was the new protocol had to support a variety of distance metrics. For example, when you use Google Map, okay, when you use Google Map, does it just considers the distance between Gantok and Ranupur? No. If there are various alternate routes, अगर यहाँ पे तो एक ही route है, so let us consider that there are various alternate routes from Gantok to Ranupur. Okay, so out of these three routes, which one does the Google Map chooses? It considers various factors. If this is 1 kilometer, this is 2 kilometer, but this is highly jammed and it takes 1 hour. But if it's free and it takes like 30 minutes, then what does the Google Map do? This is chosen as the shortest distance between A and E. Here, if you are to talk about distance with respect to kilometer, then we know that this is the optimum route. But here, due to congestion, this becomes the optimum route. So when OSPF was proposed, the second requirement of OSPF was, unlike your shortest path routing algorithm using Dijkstra's algorithm, okay, unlike this one, which was able to consider only one requirement at a time, either distance or traffic, कोई भी एक ही कर सकता था ये, okay. So your OSPF must have the capability to support a variety of distance metrics. Okay, so it should be able to support a variety of distance metrics. For example, it should consider the traffic of the network, it should consider the length, length in kilometers, it should consider the number of hops, okay, it should consider the queue, etc., etc. It should calculate the shortest considering various distance calculating metrics. Okay, so the third is very important. Now this algorithm had to be a dynamic algorithm. It cannot be a static algorithm. So it had to be this new algorithm has to be dynamic algorithm. Okay. Fourth is the new OSPF is that it has to support routing based on type of service. Okay, the new protocol has to be able to route real-time traffic one way and the other traffic are different. Okay, whenever a real traffic comes in, if I have A and B, okay, so it should consider real traffic. ये कोई तो भी assumption में नहीं चलना है, ऐसे buffer, वैसे buffer. Let us assume this buffer. If burst comes in, we open that tab. We got no, not all that thing. Okay, it should consider real traffic, and if there is a route 1 from A to B, okay, and more traffic comes in the internet, then it should be able to use the second best route, the third best route, the fourth best route, like that. Okay, now that means in fourth what did we study? We studied that it should route, okay, put all this traffic in the, it should route real time traffic. So now, to handle this real-time traffic and not to make any particular path too congested, it should do load balancing. That means it should choose the first best route, the second best route, the third best route, like that, so that there is no congestion in one particular route and the packet keeps dying. No, it should not be like that. Okay. So now the sixth point is, all these were the requirements of OSPF. Okay, so the sixth part is here, it should support for hierarchical system. Okay, because there were too many networks, it should support for hierarchical system. For example, if something comes into the Sikkim University Computer Application Department, it will come to the router of the Sikkim University, and from that router it will be directed to the computer application department router, and then from here it will be diverted to the end device. So this hierarchy should be there. Okay, this hierarchy should be there. So it should support hierarchical structure. Okay, so now seventh is, some medium of security was required. Now it should also incorporate the security features in the internet. That's why we have HTTPS, etc. Okay, we have password to conversion, MD5, message digest, etc. over the internet. In the internet, if you are doing SBI login and if you enter your password as others at the rate 123, then the server of the SBI does not receives others at the rate 123, right? That the moment others enters others at the rate 123 in his computer, that is a message digest algorithm is executed and it is converted into some other form. That form travels through others' machine to the SBI server. Okay, so various security measures have to be considered in your OSPF, and it was considered. Okay, it had to handle all this spoofing that happens over routers and all this sniffing that happens over the internet, spoofing of the router, sniffing of the internet, attack over the various security measures has to be considered. That is why when OSPF came into the picture, IETF, Internet Engineering Task Force, they started exploring, and the research in the security also became a big deal, and it was a big market, the security market after OSPF. Okay, and then finally in 8, okay, finally in 8, your the provision was needed for dealing with routers that are connected to the internet via a tunnel. Okay, the tunnel means VPN. We know that you might have done VPN or not. Okay, so when we do VPN, we do a direct connectivity between two nodes. Okay, so let us say these were the various nodes. Now this was computer A, this was the server of something, let us say some movie server or torrent. So now torrent is not allowed in computer application. So what do you guys do? आप लोग जो allowed नहीं है उसको क्या करते हो? You install some VPN. So what do? You create a direct tunnel between these two. Now it is not visible to any other network SU ka. Okay, so with this tunnel, by installing the VPN, you do all the illegal things that you are not supposed to do. Okay, but VPN was originally proposed for a very good reason, for security reason only. Okay, so whenever there is a tunnel like concept, then your OSPF must have mechanism to let it be in the internet. Okay, so to let it be in the internet, so it also had to take care, or let us say deal with the internet via, let us say, via tunnel. Okay, so when we do tunneling, okay, there is a point to point network. There is a point to point network. So internet must deal with the various types of connections. Because of this reason, the internet must deal with the different kinds of connection. Okay, so basically there are three kinds of connection. There are three kinds of connection. Okay, the first is your point to point. The first is your point to point. Okay, that means two computers are directly connected to one another. There is no point in between. Next is your multicast. You cast to a group, okay, or multi-access, you can say. You can access multiple in one go. Okay, so the third is your the second is your multi-access, okay, wherein we have a group, okay, wherein we have a group and we forward only to them, okay, in one particular network. Next is your multicast. Listen carefully. Multicast with broadcasting. Multicast with broadcasting. Okay. For example, let us say say there is one particular cricket match, live cricket match. Okay, so live cricket match. Let us say three channels bought this live cricket match to be shown in their channels: Setmax, Star Sports, and ESPN. So now this is multicast because there are three casts here. There are three casts, and in each cast there are multiple hosts. So now in this multicast, it will be broadcast. So in this multicast, it will be broadcasted. So multicast is you do only to three first. Only three computers, let us say initially, but now there are three big channels, each with broadcast. Okay, so there are three kinds of connection that is possible over the internet, and your OSPFs must support all of them. Okay, so till here, is it clear?
Yes, ma'am.
So you are a OSPF because it is a very renowned, still used algorithm over the internet. So that is why it is huge, because with it OSPF has brought a lot many concepts. ये थोड़ा ज़्यादा lengthy हो जाएगा. Okay, so let us study now OSPF first. Now you listen carefully. Now your OSPF operates. Okay, यहाँ पे term में I'm not explaining here because you already know shortest path first means you have to go for the first shortest path. And open, I've already told you, every node in the network must be open in the internet. That means it should be visible to all other nodes. Okay, that is why the term open here. So now your OSPF operates by abstracting the overall collection of actual network routers lines into a, listen carefully, directed maps. Okay, because the size of the network is humongous, how to handle that? Okay, so for that, every network, every line, every node in the OSPF, for that a directed map is prepared. OSPF क्या करता है, जो भी नेटवर्क होता है उसका एक डायरेक्टेड मैप बना के मेमोरी में स्टोर करता है. ओके, इन विच डायरेक्टेड मैप में क्या होता है, in which each are assigned a cost, distance, delay, etc. हर एक मैप का जो लाइन होता है उसमें डिस्टेंस भी होना पड़ेगा, कॉस्ट भी होना पड़ेगा, कितना पैसे लेंगे इतने से उतना चार्ज करने ट्रैवल करने के, दैट मीन्स टाइम, everything. That's why you pay in kbps, mbps, gbps, the cost is different, right? It then, after it views the assigned cost, distance, delay, let me write down cost, distance, and delay. Okay, based on these three only, the shortest path is calculated. Based on all these things, only the shortest path is calculated. Now a serial connection between two routers in that graph I'm talking about. Okay, a serial connection between two nodes in the directed graph is represented by a pair of arc, not a straight line. Okay, an arc, like a arc like this is used to represent. Now if information flow is possible from this node to this node, this node to this node, then we do two arc like this to show it can go from here to here and information will come from there to here like this. Okay, in the directed graph. The weight may be different. Okay, a multi-axis network is represented by a node for the network itself. ओके, हर मल्टी नोड के लिए हमें एक अलग अलग पाथ बनाना है. ओके, सो लेट्स convert. Let's do the first part. Okay, let me first draw. You draw the graph along with me because I don't have enough space to do the network diagram first and then the graph second. So first I'll draw the network diagram. You draw it quickly, and from the diagram I erase the diagram and I'll draw the graph. Okay, so let us say I have here, let me write down I have here A, B, C, and this is the LAN to which they are connected. Okay, so I have here node A, I have here node B, I have here node C. Okay, this is A, this is B, this is C, and here I have LAN ports. Let us say this is the network diagram. Okay, so you can say that this is one autonomous system. You can say that this is one autonomous system. Okay, so now this C is connected to the D. This C is connected to the D, and this D is connected to the E. This D is connected to the E. So now this D and E, okay, so this D and E is there in one WAN. Let us say this is WAN 1, wide area network 1, and this D and E is the router of this WAN 1. Okay, so far how many nodes we have? A, B, C. C is connected to this router D. D is connected to this router E. However, C that is connected to this router D belongs to a different network WAN 1 here. Okay. Now, this E is also connected, let us say, to a different WAN. WAN 2. Okay, so let us say now WAN 2 is connected to a node called F. When I say node here, I mean router. First, give me 1 minute. Okay, so now let us say it is connected to F. Okay, so now this F is connected to WAN 2. This F is also connected to, let us say, I have here router J, and this router J is connected to this network. F is connected to this network, and this network is, let us say, I have LAN 2. Okay, let us say I have LAN 2. So now J is connected to, sorry, this LAN 2 is connected to a network.
While talking about their experiences, Gordy asked Jamie if he saw anything disturbing,
I, let us say I. J is connected to a node I. Now I is connected to a node H. Now this H is connected to this WAN 2, and let us say WAN 3. So by far we have 3 WANs. Okay. So now the D, how is it connected to other part of the network? This D, let us say it is connected to G. Okay, this G is connected to WAN. So this is the overall network we have. Okay, so this is the overall network we have. So now the moment this network is there, remember in OSPF, every autonomous system or the OSPF needs to know the topology of every network. That means now this internet is implementing OSPF. Now OSPF needs to know the topology of this, topology of this. So if it says the overall topology is this one. So the first thing that OSPF does after it takes the structure or the blueprint of the network is it converts this network and draws a directed graph for this one. Okay, so now because I will have to erase this, I'll just show you how do we draw directed graph. So I have here A, LAN 1, B, LAN 1, C, LAN 1. So I will draw something like this. Okay. So I will draw here LAN 1. Okay. So I'll have here A, B, C. So for LAN 1, LAN A can send to LAN 1, A can receive from LAN 1. So this is like A can send to LAN 1 and LAN 1 can send to A. Okay, so now A can send to B, B can send to LAN 1 like that. Okay, so here C and here I have D. So C can obviously for B also I'll do the same thing. So C will send to D, D will send to C. Okay, so now this D can send to this man, this D can send to man, so I'll do like this also. Okay, so this is how now we are going to draw the diagram. Okay, so have you taken down this autonomous system का ये diagram आपने draw कर लिया this network? Vikas, did you draw this? I can erase it now, no?
Yes, ma'am.
So let us do.
Here's music coming from the radio. After turning it off, she records a video on her phone.
So now I have here
Not scientific discovery.
A,
Suddenly,
B,
radio
and
started
C.
playing again.
So A, B,
Investigating why is Tesla
C I
running
have.
ads?
Okay, you refer to your diagram.
Search easy for
Now I have here LAN 1. So now it can send to this one. Okay, this should be an arc. Okay, you have to use arc. LAN 1, this one. आपको arc use करना because it's a directed graph. You have to use arrowheads. It can send to C. It can receive from C. This was the basic structure before. Okay, so there was a D here. Okay, so there was a D here. So C can send to D, D can send to C because they are open in each other. Okay, so I had D. After D here, I had E here. Okay, I had here E and I had here WAN 1 if you remember. Okay, यहाँ पे मेरा WAN 1 so D E को भेज सकता है, E D को भेज सकता है, D WAN 1 को भेज सकता है, WAN 1 D को भेज सकता है. Okay, so WAN 1 भी E के साथ connected था. Look at the graph. WAN 1 was also connected to E. So WAN 1 can send to E, E can send to WAN 1. Okay, so now your E was connected to WAN 2 in the graph. So I have here WAN. Now E can send to WAN 2, WAN 2 can send to E. E can send to WAN 2, WAN 2 can send to E. Okay, so now your WAN 2 was connected to F. Now WAN 2 can send to F, F can send to WAN 2. So हमने यहाँ तक खत्म कर दिया. Okay, so now your D here was connected to G here. So let me draw. So D can send to G, G can send to D.
Sometime later during class,
Okay,
Sophia
यहाँ
has
पे
vision
हमारा
change. Do
G
you think she's getting
था. So
insulted?
now here I had, I think WAN
This is a
3.
video of her sleeping with Jamie appearing on computer screen.
So G
On
can
set, she
send
leaves the
to
room, makes a
WAN
phone,
3,
where she
WAN
hears
3
a girl's
can
laughter,
send
and afterwards she
to G.
walks behind her.
Okay,
Sophia
and
enters
then
the
here
elevator
I
and
had
notices that
H.
the is missing, but she can't
WAN
get out
3
because
can
the door is
send
already
to
closed.
H,
The
H
elevator
can
starts
send
going
to
up, suddenly
WAN
stops in
3.
the
If
hallway.
I'm missing
Last
anything,
year, she goes
just
on.
let me know.
Starting
Okay,
Sophia back
and
in
then from
reality.
H I
Grace
had
is
here
off on her
I.
post and Hillary discovered she changed Iris'
So
phone on her report
H
to make
can
it dead
send
by
to
accident.
I can send back to
Asked her to
H.
help relieve the need. Mother refuses to do it because of the
So
short
here I
Grace tells her
had
that she should be a
LAN
doctor.
2.
Meanwhile, Sophia
Here
has
I
changed
had
what the nurses
LAN
Sabrina.
2. I can send to LAN 2, LAN 2 can send to F. And then F and L2 were connected. So F can send to L2, L2 can send to F. So here I have J, that is where size was, this was LAN 2. J can send to LAN 2, LAN 2 can send to J. So this is the direct graph that OSPF will draw from the blueprint and it will keep repeating. Okay, it will keep repeating. So is it done? Is it finished?
Your car, crying as she drives. Another hallucination begins with the plane. A pair of hands with a plastic bag around her head, making it hard to breathe and causing her to crash. Ray gets a message from Marlo saying she needs to stop all this. So he calls Sophia and Jamie to help him look for them.
So now after this graph is considering that you are finished, after this directed graph is drawn, so whatever weight was assigned in the previous graph, okay, जो भी weight assigned the distance, kilometer, that will be assigned over the side. So let us say here from A to B it is 2 kilometers. Okay. So let us say for this one it is 3. So now we know that if it is 2 from L1 to A, from A to L1 also it will be 2. Okay. So let us say it is weight 3. For C it is weight 2. Let us say C to D it takes 4. Okay, so this weight will also be given. This will be a weight directed graph. Directed graph, the graph is of two types, directed and undirected graph. Now both directed and undirected graph are of two types, weighted directed graph, non-weighted directed graph. Weighted undirected graph, non-weighted undirected graph. So this directed graph will be a weighted directed graph where the weights of each node is written here. Let me write down, let us say this is 6, this is 1, this is 2, this is 3, this is 4, this is again 6, let us say this is 10, this is 11, this is like 4, this is like, let us say 3, this is like 6, this is like 5, like this. Weight will also be written here. So is it clear till here? This is the first step of OSPF class. Is it clear?
Yes, ma'am. Yes, ma'am.
Okay. Okay. So now a bit of theory again. So now many of the autonomous systems in the internet are themselves large. Okay, many autonomous systems themselves are large. For example, just imagine the size of the network of SU. This is one autonomous system. It is immense. It is huge. Okay. So now when this autonomous system will be brought into the internet, the size of the AS itself is huge. Okay. So now many a times even the state of the network is considered as autonomous system. For example, considering Goa and Sikkim, because these are the two smallest states, first Goa, second Sikkim. It may, I don't know if it has really been done. The government may have considered Goa as one autonomous system because it's small. Again, the population of Sikkim is small, so Sikkim network is autonomous too. So if Sikkim itself is an autonomous system, just imagine the size of the autonomous system. Okay, so many of the time, autonomous system in itself is, the internal autonomous system in itself is so huge that it becomes non-trivial to manage. Thus, your OSPF allows to divide the internal of this autonomous system. That means the autonomous system internally is divided. Okay, so let me draw one autonomous system to explain that. So many questions for so many number of times have been asked from OSPF in GATE exam. Okay, so let us say this was the autonomous system now. Because it is so huge, inside this autonomous system, the network is divided into different parts. Now, so each of this now here is called as area. So let us say this is area 1, this is area 2, and this is area 3. Okay, so the autonomous system, if it's huge, it is divided into areas. Now these areas cannot overlap with one another. So let us say that there is this router. This router belongs to area 1 and also to area 2. So if we will put this router here and put this in area 1 and area 2 both, then there will be overlapping, but we cannot overlap this. So in such situation, we can leave this open. So it belongs wholesome to the autonomous system. Okay, so we cannot have any overlapping here. That is, some routers may belong to no areas. In this case, we say that this router does not belong to any area. Now, what is an area? It is a sub-realization of a sub-realization. We know that AS, autonomous system, is a subnet. Okay, so your area is a sub-realization of a subnet. Outside an area, it's topology. Okay, so now outside an area is area ke bahar. The topology of this one and details are not visible to other area. The topology, the details of the nodes, routers of area 2 is not visible to area 3. The topology of router 3, the details, the weight, the graph of area 3 is not visible to A or to 2. Okay, so now because we have to maintain the security, then how do they interact with each other? For that, there is one router is voted. Okay, then there is some different types of router that is used here, that is used here, that is used here. Okay, so now every autonomous system has a backbone area. Now let us say this area. Out of this three, one area will be voted as a backbone area, and then every other area in this autonomous system is connected to this backbone. So if this is area, so one of this router for area 2 will be connected to backbone का एक router में. One of this router from here will be connected to another router in the backbone area. One router from here will be connected to another router in the backbone area, similarly here, and then here they will be connected to one another. So that if any computer from here wants to send a message here, it will go to the backbone, and from backbone it will come back. Why? Because they cannot see topology of one another. This computer here does not know the destination computer whether it is here, here or here. So for that reason, a backbone area is designed, and each router from the area is connected to at least one router in the backbone, and these routers in the backbone are interconnected to one another so that information flow is possible. Okay, so now this autonomous system has a backbone area, and now this backbone area is called as area 0. The backbone area is given a name. बाकबोन में बहुत सारे area है. Okay, but out of this, which one is backbone area? That backbone area will be called as area 0. All areas are connected to the backbone possibly. Now this connectivity between this area, between the area is possibly done through tunnels, so that the security bridging becomes less possible. Okay, so now within an area, each router has the same linked state database and runs through the same shortest path algorithm first. Within the area, the algorithm has to be same, no matter how big or small it is. जो routing algorithm use हो रहा है हर area के अंदर, it has to be same. Whatever algorithm runs in this router, same has to run. Within area, every router must run the same shortest path algorithm. Its main job is to calculate the shortest path from itself to every other router, including the router that is not connected to the backbone. Okay, ऐसा नहीं है कि सिर्फ backbone router से जो connected है वो. No, all the routers, whether it is connected to the backbone or not, Okay, it has to find the shortest path. Okay, so now because of this reason, okay, so because of this reason, your routing, okay, your routing is divided into three types. There are now, because of this reason, there are three kinds of router needed. There are three kinds of router because we are dividing the internet into autonomous system. Autonomous system is divided into area. Area is divided into backbone area and non-backbone area. Now your each area must use same shortest path routing algorithm, and your each router must be connected to other router in the network, whether it is backbone router or not. So depending upon their nature, your router is divided into three types. Okay, one is your intra area. Intra area. Second, I think नाम से ही समझ में आ गया होगा. Second is your inter area. Third is your inter autonomous system. So now intra-area router. The router, okay. So this is the autonomous system. Autonomous system 1. This is the autonomous system 2. Let us say this is your backbone. So I've named it as 0. So this is your backbone. This is your 0. Let me draw only two areas. Area 1, area 2, area 1, area 2. 1, 2, 1, 2. Now the router that is used within an area, okay, intra area, okay, that is the intra area within a area, okay. Router are the easiest since the source router easily knows the shortest path to the destination router, okay. So this is your intra area. So now this is your inter area. Okay, this is your, देखो ये intra area को, if this is your area 1, node 1, node 2, node 3, node 4. Now if A wants to send to B, A knows about B, so he can directly send to B. So this is the simplest. But if this is area 2, if this is area 2, it does not, if A wants to send to B, it does not know B के बारे में anything. So what it does, but A needs to send to the one of the computer in the B. So what it does is, for that we have inter router. So now this router, let us say it has been voted as inter router. Now inter area routing algorithm proceeds in the steps. Go from the source. This was if inter area voted as inter area. Go from the source, as I've already said, to the backbone. Go up from backbone में अगर directly connected, go from the source to the backbone. अगर backbone से directly ये connected है, inter, very good. If it's not directly connected, this one is also inter, voted as inter router. So if this backbone router is connected to this one, go. If not, then go through the backbone. Okay, go from the source to the backbone. Go across the backbone to the destination area. Okay, यहाँ पर destination area है. So now this destination area is connected to the destination. So this is how inter functions. Okay, now next is your inter-autonomous system. So this is autonomous system 1, this is autonomous system 2. So let us say, now this router from backbone it will be selected. The router that is responsible for communicating between autonomous system के बीच में जो router communicate करेगा, that router will not be from the area. However, that router will from the backbone. Okay, 0 router. So this has been designated as inter-autonomous system router, and the limitation we can receive will be the inter-autonomous system. Is this three clear, class? Is this three type of router clear? So summary करना है तो internal routers are wholly within one area. Area border routers. Area border routers connect two or more areas. Backbone routers are on the backbone. Autonomous system boundary. Autonomous system boundary talk to routers on the other autonomous system. Okay, so this is about your different types of. With the help of that, let me clear this one also, okay, that I can use the bigger frame. So with the help of that, I'll also explain to you the principle working of OSPF. So let me draw this autonomous system 1. This is my autonomous system 2. This is my autonomous system 3. This is my autonomous system 4. Okay. So I have here autonomous system 1, autonomous system 2, autonomous system 4, autonomous system 3. So now there will be a network here. What is this network? I have not told you so far. I'll tell you later. Okay, so this is the network. So now this autonomous system, each of them will have a backbone area, as I've just told you. Okay, let us say this is the backbone router. This is different nodes. Okay, so corner here represents nodes in my diagram. Okay, let me do. This is my backbone network. Okay, so I have here the backbone first, backbone area, backbone. So let me do. This is the backbone area. So let's say only these many routers in the backbone area here. Let us say these are the backbone area. Okay. Now I am designating this one as autonomous system boundary router. Autonomous system boundary router. So let me do, this one is the autonomous system boundary router here. So let me do autonomous system boundary router here. Okay, so let me do autonomous system boundary router here. So now, what is this? I will tell you later. Okay, as of now, all this autonomous system network, okay, let me tell you, this network here now, see here, these are the different networks, different autonomous system. Now this different autonomous system must be connected to a network so that they can also communicate with each other. ओके, इंटर ऑटोनोमस सिस्टम के साथ बात करना होगा. सो दैट itself from each backbone area, I've told you one router is selected as autonomous system boundary router, and that will connect to the router to which that router is connected to other autonomous system. Okay, so this one comes in here, let us say this one comes in here, this one comes in here, this one comes in. अच्छा मुझे ये बनाना चाहिए था so that it would have been easier. Forget about this one. Okay, so I'm for my ease purpose, I'm now taking this one as my backbone router, boundary router. So this is my boundary router. Now this network here that connects this internal autonomous system is called as your BGP. That I've explained first concept. Remember, border gateway protocol. Border gateway protocol. When I taught that there was IGP, there was EGP, internal gateway protocol, external gateway protocol. External gateway protocol क्या था? That connects the autonomous system. So now to implement EGP, external gateway protocol, जैसे IGP के लिए we have distance vector routing algorithm, we have OSPF and all. External के लिए we have BGP, border gateway protocol. IGP के लिए distance vector है, link state है, I'm repeating again, but in internet we use OSPF. Okay, that we have been studying since the beginning. Now for EGP, exterior gateway protocol implement करने के लिए BGP है, border gateway protocol. What does it do? It forms a network, and in that network only those routers are there which are the backbone routers, which are the backbone routers of each autonomous system. वहाँ पे सिर्फ 4 router होगा, and it will establish a connectivity between this so that information flow becomes possible. Okay, so now here I have area route, first backbone area. So now if I have this many area here, okay, so there will be no connectivity between these two, because I've already mentioned an area here does not know the topology, distance, weight of the other area. So it will be connected to another. Now from here, one router will be designated as backbone router. Okay, backbone का boundary router बोला जाएगा. Okay, another will be elected as inter area router. Okay, one is inter autonomous system router, जो ये vote किया गया है. Now this is your inter area router, जो area के बीच में communicate कराएगा. So there may be more than one inter area router if the size is huge. Otherwise, इसमें छोटा size है, बड़ा size है, so this one is also inter area. In this case, the area is small, so there could be only one inter area router. I have again area. Okay, I have area. So it is connected to this one, So this one is again big. So let us draw more areas here, and they are connected. Let me do this one as the area router here. This one, and let me draw one more area. So this is how OSPF keeps the picture of the network as, and this is how it functions. Now OSPF, open shortest path first, works by exchanging information between the adjacent router. Okay, adjacent router के साथ information exchange करता है. Every router on the LAN to talk to every other router on the LAN. So avoid the situation of congestion, what it does is one router is elected as the designated router. एक router को ये elect करता है as designated router. OSPF votes one router as the designated router. Now this designated router is said to be adjacent to all the router on its LAN and exchanges information with them. Now this is your area. Within this, if you have LAN, out of all that router, one router will be elected as designated router. एक router को area के अंदर एक designated router बनाया गया. So typically कुछ LAN connection है and they want to send information, data, they will use the help of designated router. There was once asked what is designated router. Okay, once it was asked designated router क्या है. Okay, designated router is something which is not the same as the neighboring router. ये neighboring router नहीं होता है, but it is there to talk to every router on a LAN. Okay, but we need to talk to every other router in the LAN. So one router is voted as designated router so that it can talk to every other router in the network. Now it is said to be adjacent to all other, not neighbor, adjacent to all other routers on its LAN and disseminates the information within. Okay, now adjacent और neighbor में तो difference पता ही होगा. Now neighboring routers that are not adjacent do not exchange information with each other. Okay, for example, अगर see here. This is A, this is B, this is C, this is D. A is connected to C, A is connected to ये क्या था B, C, अच्छा D. ऐसा है. Okay. Now B is connected to, let us say, D. Now it seems that A is the neighbor of B. Okay, but A is adjacent to B. But A and B are not neighbors. Those who are not neighbors, just adjacent to one another, एक के बाद दूसरा रख दिया, adjacent to one another, but they are not neighbors. They don't exchange information. I've already told you that. Okay, I've already told you that. Now, during normal operation, each router during normal time, okay, जब चल रहा है, how do they know information about each other? During normal operation, each router periodically floods हर एक router within everywhere. It periodically floods a link state update. Remember, distance vector was there in 1979. In 1888, it was changed to link state. So distance vector floods periodically. Distance vector value we have already solved. Similarly, your link state routing algorithm periodically floods link state update. जैसे distance vector value आता है, वैसे ही link state update आता है. Link state update में क्या आता है? It provides the sender's cost to the neighbor. If I'm sending to B, B will send A का मेरे साथ क्या है? Also B जिसके साथ connected है, it will send the update link state update of all those connected neighbors. Okay, जिसके साथ A adjacent है. Now this message gives its state and provides the cost used in the topological balance. If this is your designated router for your backbone, if this is your designated router for your area, similarly, let us say this is the one, this is the one. So now what does this designated, let us say, because this is connected to backbone, let us say this is the designated router. Periodically it will flood this here, okay, with link state update. Distance vector में distance vector update के लिए मांगता है, यहाँ पे link state जैसे ही आएगा, it will just like distance vector, it shares the information, it will do so with the neighbor and the database is updated. Now the flooding messages are acknowledged to make them reliable. Whatever message is being flooded to all the other routers here, those receiving routers will have to acknowledge those flooded message so that it becomes a reliable service. Internet becomes a reliable service. Now, every message that is being flooded will have a sequence number so that at the time if a router receives an old flooded message, it does not get confused. Duplicacy doesn't occur. Because of that, each of this message is given some sequence number to understand the position of the packet. Now, for what? To know that whether an incoming link state update is an older one or a newer one. Okay, so now routers also send these messages when a line goes up or down. We know that if in here, anywhere, if a router goes up or if a router goes down, now that information, you have studied count to infinity problem. What is count to infinity problem? It occurs when in distance vector, when a router goes up or down, that information has to be shared with all the other routers so that path that was not there earlier is now active, right? So that path can be used. उसमें क्या हमें स्प्लिट करना पड़ता है, वो न्यूज स्प्लिट करते होते डिस्टेंस वेक्टर राउटर में यूज टू सफर फ्रॉम काउंट टू इन्फिनिटी प्रॉब्लम. सो वो ना हो, okay, वो ना हो, every router has to send a message when a router goes up or down. अगर पहले ये down था, अब ये up हो गया, it will send this information to all the routers within and it will send this information to the backbone router. If this backbone router was down and we have a backup backbone router now, so it was down, so it was informed here. So now when it goes up, the backup boundary router must inform that to this way. जब भी up or down होगा. For that, which packet is being used? For that, link state request packet is used. Okay, for that, link state packet is used. For acknowledgement, link state ACK packet is used. हमें जब अपडेट चाहिए, डिस्टेंस वेक्टर वैल्यू जैसे होता है वैसा जब चाहिए, वी यूज द पैकेट नेम लिंक स्टेट अपडेट. Okay, link state update. For acknowledgement, we use link state ACK. Okay, and then when we want to request for a partner, we use link state request packet. Okay, so now this is how your OSPF works in summary. So this is all about your OSPF. ओके, अंदर लिंक स्टेट होगा, राउटिंग होगा. ओवरऑल कैसे कंबाइन होता है एक दूसरे के साथ, बीजीपी कैसे आता है, दिस इज योर बॉर्डर गेटवे प्रोटोकॉल. इट ब्रिंग्स ऑल दी autonomous system bounding router into one network. And now if AS1 wants to talk to AS2, they cannot do directly. AS1 का जो भी router wants to talk, it has to forward that request to AS boundary router. Now if this router wants to talk to AS2, or if this router wants to talk to AS2, or if this router wants to talk to AS2, कोई भी router wants to talk to AS2, they cannot do directly. If this wants to talk first, it has to be forwarded to this router here. Now this router will forward it to other, and finally it will reach the AS boundary router. Now AS boundary router again cannot forward this to this router directly. However, it has to forward it to this one. Looking at the topology, it will be forwarded to the respective router, and then from here it goes to the AS2. So ये बीच वाला network and topology is called as your border gateway protocol. Again, inside this border gateway protocol, it is not so huge. ये बहुत बड़ा नेटवर्क नहीं होता. यहाँ पे एक राउटर ही होता है यूजुअल. एक मतलब not just one, but for each autonomous system, one router is there. So usually inside this one, distance vector routing algorithm is used. If the size increases, link state routing algorithm is used. That is an updated version of your distance vector routing algorithm. Again, here each link state, inside this one link state. Lekin this all idea of autonomous system, backbone area or area 0, area 1, area 2, area 3, designated router, boundary router, area router, backbone routers, border gateway protocol routers. Okay, this autonomous system connecting with each other via a secondary router, this overall makes your OSPF. And for that, OSPF uses 5 types of messages. Hello to know the neighbor, hello packet to know the user, link state update to get the update of the neighbors like your distance with the router. Once it is flooded, it has to be acknowledged. For that, link state ACK packet. Now which update has to be sent to which router? एक database maintain होता है. For that database description, now we want to request information from partner. If I want to request some information from my routing partner, then I request that with the help of a packet called as link state request packet, like flood syn packet, sek packet, ये सब packet का नाम है that are used in your OSPF. So this is all about your open shortest path first. So is it clear? OSPF, can I move to the next topic now?
Yes, ma'am.
Every Just give me 2 minutes to drink warm water. I'll come back. I'll just drink water and come back. Okay. Okay. So now there is one small topic now. Two small topic actually. Okay. Now we are going to study. We studied OSPF. Okay, open shortest path first, and then we learn that in OSPF it implements various types of algorithm. Okay, there also I've told you that it OSPF brings into picture IGP and EGP, interior gateway routing protocol, and your exterior gateway protocol. Okay, so let me explain. Exterior इंटीरियर के लिए हमने कर दिया है OSPF. Now we have exterior gateway protocol. I told you there are four types of protocol by TCP/IP. Internet protocol में दो है. One is your IGP, Interior Gateway Protocol. So for that we studied OSPF. Another was your EGP, Exterior Gateway Protocol. Okay, IGP के लिए OSPF है, EGP के लिए BGP है, Border Gateway Protocol. So we have already studied border gateway protocol, but there are something that you must know about exterior gateway protocol. Why? Because interior gateway protocol is within a country. एक country के अंदर होता है IGP. So it does not not much thing has to be considered. For example, if our traffic is coming to Sikkim from Kolkata, it doesn't matter. There is nothing to be special thing that is to be taken care of. If to Tamil Nadu traffic from Kashmir is going via Sikkim, no, nothing to worry. To Nagaland from Manipur, Mizoram, within a country there is no other issue. It is just the issue of routing correctly. Okay, but now when we have different countries, okay, to connect an internet, when we are using EGP with the help of BGP, दिस इज योर एक्सटीरियर गेटवे प्रोटोकॉल. नाउ ये हर एक अलग कंट्री का ऑटोनोमस सिस्टम को हमने एक में लाया सो दैट वी फॉर्म द ग्लोबल नेटवर्क. ग्लोबल नेटवर्क बनाने के लिए सो दैट इज माय एक्सटीरियर गेटवे प्रोटोकॉल. वो बीजीपी से होता है. हाउ डज इट हैपन दैट आई हैव ऑलरेडी शोन. But when we do exterior gateway protocol, it is not as easy as IGP. Why? When we do EGP,
और एक्सीडेंट हो
connect
गया
to
तो
the
मिल
network of different countries, other than routing, politics has to be considered. Security of the country has to be considered. For example, a traffic that is coming from US to India, US security forces to Indian security forces. ओके अगर यूएस सिक्योरिटी फोर्सेस से इंडियन सिक्योरिटी फोर्सेस में कोई इंफॉर्मेशन आ रहा है. फॉर एग्जांपल रॉ इज गेटिंग सम इंफॉर्मेशन फ्रॉम यूएस का क्या होता है एफबीआई that some bombing is about to happen in India, if something like that, then it's obvious that traffic cannot come from Pakistan. We know that it's the shortest route to India. The shortest route is from Pakistan, but because it is about the security of the country, now if the autonomous system, sorry, if the boundary router of India was connected to Pakistan, no, we cannot let that happen. So when we talk about exterior gateway protocol, जब हम BGP बना रहे थे with various autonomous system in my previous diagram, when we do this connectivity for EGP to bring a global internet, then we cannot just keep in mind the routing, finding the
हाँ
shortest
होगा वो
route,
बुक
but
तो
we
कर
also
दीजिएगा
have
फिर
to keep in
डिलीवरी के
mind
लिए
various policies, various security. As already mentioned, a traffic from FBI to RAW in India cannot come from Pakistan. Why? ISI will decrypt all that crucial information. Okay, so when it is exterior gateway protocol, we implement it with the help of border gateway protocol BGP. So now within a single autonomous system, the routing mechanism is known as IGP, and there is nothing to worry. But autonomous system, when different talk to one another, then we have BGP. Okay, as I've already mentioned. Now when such thing comes into picture, there are various things that has to be considered. So let me point out all of them one by one. Okay, now no transit traffic through certain ऑटोनोमस सिस्टम. एक ऑटोनोमस सिस्टम से दूसरे ऑटोनोमस सिस्टम में traffic cannot be there between certain autonomous system for certain reason. For example, a traffic from Microsoft to Apple, a traffic from Microsoft to Apple cannot come via IBM. Why? Because they have business rivalries. It cannot be so. माइक्रोसॉफ्ट से एप्पल से डायरेक्ट बात करना पड़ेगा, एप्पल से माइक्रोसॉफ्ट डायरेक्ट. इट कैन नॉट बी बाय IBM नॉर वाइस वर्सा. सेम, Apple wants to talk to IBM, it cannot come via Microsoft. So certain transit cannot come through certain autonomous system. Number 2, never put Iraq on a route starting at the Pentagon. हमें पता है पेंटागन के साथ क्या हुआ था. कितना हो गया ये 1 2 3 4 5. ओके, तो कोई भी ट्रैफिक अगर पेंटागन के पास आ रहा है तो बीच में इराक मत डालो, बीच में इराक को मत डालो. दे हैव पॉलिटिकल इश्यूज. Only transit Albania if there is no alternative to the destination. Now Albania, we know that it is all terrorist place. Okay, so now to whichever country we want to divert the traffic, don't divert it through Albania. Do it only if there is no other route, कुछ possible ही नहीं है, then only do. Otherwise never divert your traffic through Albania. Okay, like this. ऐसे ही बहुत सारे business rivalries, country rivalries, all of this. For example, let us consider your family rivalries now. Okay, let us take a simple example of television. Let us say there is family one here, there is family tree here. Now they are in good terms. They are in good terms. So they decided to share their cable line so that they'll pay half. Pehle cable wala. But now there is a family in between, to which family 2 shares bad terms. Okay, so they have bad terms. Now family 1 cannot send their cable through the building of this family now. Obviously they will chop it off. Okay, so such types of rivalries has to be transferred. Okay, so this with this we have finished various protocols. The last one small topic is your मोबाइल आईपी. ओके, मैं डिटेल में नहीं पढ़ाऊंगी, ये थोड़ा सा बता दूंगी. यू कैन एक्सप्लोर ऑन योर ओन. ओके, मोबाइल आईपी. Mobile IP, the internet addresses that, or the internet protocol that addresses the moving nature of any network is called as your mobile IP. Okay, the internet protocol that addresses the issue of the movement of anything is called as your mobile IP. For example, if you are here right now and next moment if you are traveling here, so how to handle all this comes under your mobile IP. For that, a mobile address IP is given, mobile IP is given, which changes frequently. Let us say this is Gantok, this is Siliguri. So it changes constantly. But along with the mobile IP, one more IP is there for your device. No matter how much you move, this is called a static IP. When you are moving, this is what happens. Static IP is given. This will never change, so that the destination device is always fixed. With that, a mobile IP is given that constantly keep changing the geographical destination. So the static IP from your mobile gives your information to the mobile IP of your mobile only, and then it will be sent to the base station. Base station will try to find this changing mobile IP. Now, if this mobile IP is changed, by the time he has moved, it has already been mapped to this static IP. The change will map to the static IP and it will give to the user. Again, this mobile IP keeps changing as you. Okay, so the next topic was your mobile IP. This was your basic IP. Okay, so with this, OSPF, IGP, IGP versus EGP, IGP say OSPF, EGP say BGP. We have with all this topic, and then mobile IP, we have finished your network layer. We have finished your network layer. So from the next lecture, we'll start with the transport layer. Okay, हमने network layer को खत्म कर लिया है. So the next topic is your transport layer. So if you have any queries from today's lecture, post your queries. If none, leave the classroom, and from tomorrow next lecture we'll start with your transport layer.
शहर के चलाने के हिसाब से तो सही बात है ये.
और आपके नेक्स्ट वीक मैं आपका सेशनल 2 लूंगी. ओके, I'll give you one day from the next week and then I'll take your conduct your seasonal 2.
हाँ.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you. Thank you. Thank you. Thank you. Video?
एक सेकंड.
Yes, ma'am.
मैंने आपको ईमेल किया था, चेक किया आपने?
Ma'am,
चलिए हो गया मेरा. एक क्लास चल रहा था बगल में. मतलब हेलो. मतलब